Practice exam number 2. So the problems on this practice exam are nearly identical to those problems that you have on your actual exam. The majority of problems will look identical, but maybe the only difference is the numbers may be different. So let me do problem number 1. Oh, and I guess when I go over this exam, I will give you several different techniques to be able to solve a problem. When you solve a problem, you'll only be using one of the techniques. Maybe you will decide that you want to use the TI-84, and you'll follow those steps that I give you for the TI-84, or maybe you want to do everything by hand, and you'll follow those steps when you do everything by hand. So I may give several differing solutions to one particular problem, but in your particular case, you'll only be doing one of those. When I do a problem, the amount of work that I show is the amount of work that I would expect that you would show on your PDF. And if you did not show the same amount of work on your PDF, you may not get full credit. You may get little, if any, credit if you do not show any work on a particular problem. So let me do problem number 1. 26 of 110 digital video recorders, DVRs, in the inventory are known to be defective. What is the probability that a randomly selected item is defective? Express your answer as a percentage rounded to the nearest hundredth without the percent sign. Let D be the event that the DVR is defective. I want to find the probability that, well, the randomly selected DVR is defective. Well, 26 of the 110 are defective. And so I get 0.2363636363636. Rounding, moving my decimal place 2 places to the right, I have 23.6363636%. Rounding to the nearest hundredth of a percent, well, I have the digit 3 here. The digit immediately to its right is a 6. Since 6 is greater than or equal to 5, then I'll round the 3 up to a 4. So 23.64%. Problem 2. Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that the orders are randomly selected from those included in the table. And so here's my table. If one order is selected, find the probability of getting an order that is from restaurant A or an order that is not accurate. Express your answer as a percentage rounded to the nearest hundredth without the percent sign. So let A be the event that the order is from restaurant A. Let N be the event that the order is not accurate. So I want to find the probability that of A or N, the probability that my order is from restaurant A or that is not accurate. And so let's add these all up. So 17 plus 10 plus 19 plus 20 plus 22, 88 over, well, let's find the grand total. So first, let's add up each column. So 39, 15, 22, 41. And then let's add all these up. So 39 plus 41, 80, plus 15, 95, plus 22, 117. And so we have 88 over 117, 0.7521367521. Move my decimal place 2 places to the right. So 75.21367521%, round to the nearest hundredth of a percent. And so 75.21%. Problem 3. Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that the orders are randomly selected from those included in the table. And so here's the table. If 3 different orders are selected, find the probability that they are all from restaurant B. Assume that the orders are selected with replacement. Express your answer as a percentage rounded to the nearest hundredth without the percent sign. So let B be the event that the order is from restaurant B. And so let's add up each of these. So I have 43, 95, 50, 35. Let's add up these. We get 103, 120. Let's add up these. So we get 223. So let's find the problem. So I want to find the probability that, well, the first one that I pick is from restaurant B. Well, let's see. 95 of the orders are from restaurant B out of a total of 223 orders. So it's 95 out of 223. Now, since we assume that these are selected with replacement, then each of the events are independent. So selected that was from, restaurant B or whatever, well, or any of the other restaurants, then you put it back into the pile again. And so there will still be, for the probability that the second one that you choose is from restaurant B, it will still be 95 out of 223. The probability the third one that you choose is from restaurant B will still again be 95 out of 223. And so it's 95 out of 223 quantity cubed, 0.077313658 Move my decimal place 2 places to the right, 7.73136589%, round to the nearest hundredth of a percent, 7.73%. Problem number 4. Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that the orders are randomly selected from those included in the table. If one order is selected, find the probability of getting an order from restaurant C given that the order is accurate. Express your answer as a percentage rounded to the nearest hundredth without the percent sign. Okay, so we want to determine the conditional probability. We are given that the order is accurate. So I'm going to restrict my sample space to only those where their order is accurate. There's a total of 87 of those. And so we have a total of 87 orders that are accurate. Of those, let C be the event that the order is from restaurant C, and let A be the event that their order is accurate. So I want to find the probability of C given A. And so I restrict my sample space to only those from restaurant C. And so there'll be 20 out of 87 because I've restricted my sample space to only those where the order is accurate. And so 20 out of 87, 0.2298850,575. Let me move my decimal place 2 places to the right. So 22.98850,575%, round to the nearest hundredth of a percent, 22.99%. Problem number 5. A study conducted at a certain college shows that 38% of school's graduates find a job in their chosen field within a year after graduation. Find the probability that among 8 randomly selected graduates, at least one finds a job in his or her chosen field within a year of graduating. Assume that the sample is taken with replacement. Express your answer as a percentage rounded to the nearest hundredth without the percent sign. So I'm going to look at the complementary event. It's easier to, we're trying to find at least one. And so it's easier to find, rather than at least one, to find the complementary event of at least one. I have here that this is a binomial distribution, a binomial random variable. I have a fixed finite number of independent trials, 8. I have a success for each trial, which is that the college graduate from this school finds a job in his field within 1 year of graduating. And we have a fixed probability of success for each trial, 0.38. So I want to find the probability of at least one. And so I want to find the probability that X is greater than or equal to 1. And so let's look at the complementary event. The probability that X is less than 1. Well, there's only one number less than 1, 0. So I want to find 1 minus the probability X is 0. So 1 minus, in this case, I'll use the binomial probability formula. So 8C0, 0.38 to the 0. If I have a 38% probability of success, I have a 62% chance of failure. So 0.62 to the power 8 minus 0, 8. And so 1 minus 0.62 to the 8th, 0.9781659894. Let's move my decimal 2 places to the right. So 97.81659894%. Let's round this to the nearest hundredth of a percent. So 97.82%. I can also use my TI-83, TI-84 to find this. So again, we'll be using the complementary event. This is a binomial distribution with n equals 8, p equals 0.8. So to find the probability X is greater than or equal to 1, I'll just do 1 minus the probability X is 0. So I'll use the binom PDF command. So 1 minus binom PDF 8, 0.38, 0. And so let me use technology to compute this. And so let me input 1 minus binom PDF. There are 8 trials, 0.38 probability of success for each trial, and I want to get rid of the 0. And so I get 0.9781659894. And so let me put that, let me write that number down. And so we have here 0.97, oops, 0.978165989894. And so moving my decimal place 2 places to the right, I have 97.81659894%. Rounding to the nearest hundredth of a percent, I have 97.82%. Well, we can also use Excel. So let's use Excel. So again, we'll be doing the complementary event. We have a binomial distribution with n equal 8, p equal 0.38. I want to find the probability x is greater than or equal to 1. So let's find 1 minus the probability x is 0. So 1 minus binom dist 0, comma 8, comma 0.38, comma false. And so let me use my Excel to calculate this. And so I'll do 1 minus binomial distribution, where I'll get rid of everything less than 1. So get rid of 0. I have 8 trials and a probability of success of 0.38. And I'll use the PDF. And so I have here 0.97816599. And so let me write that on my iPad. And so we have here 0.97816599. Let me move my decimal place 2 places to the right. And so I have here 97.816599%. Rounding to the nearest hundredth of a percent, I have here 97.82%. So I can use Mathematica to do this. So again, I will be using the complementary event. We have a binomial distribution. N is 8, p is 0.38. I want to find the probability that x is greater than or equal to 1. That's 1 minus the probability that x is 0. And so I'm going to do 1 minus PDF, binomial distribution, 8, comma 0.38, comma 0, and I'll evaluate that. So let's use Mathematica. And so let me type in the following command. And so 1 minus by the PDF for the binomial distribution with parameters 8.38, and I want to get rid of everything less than or equal to 0. And so I get here 0.978166. And so let me type that into my computer. And so I have here 0.978166. Move my decimal place 2 places to the right. So I have 97.8166%. Rounding to the nearest hundredth of a percent, I have here 97.82%. And so let me use R. And so we have a binomial distribution. N is 8, P is 0.38. I want to find the probability x is greater than or equal to 1. So the same as finding 1 minus the probability x is 0. So I'm going to type in 1 minus D binom 0, comma 8, comma 0.38. And so let me do that. And so let me type in 1 minus D binom. I want to get rid of everything less than or equal to 0. 8 and 0.38. Well, I guess I'm just getting rid of 0. And so I have 0.978166. So let me type that onto my computer. And so we have 0.78166. Let me move my decimal place 2 places to the right. So 97.8166%. Let me round to the nearest hundredth of a percent. So 97.82%. Okay, we can also use StatDisk. So let's use StatDisk. And so we have a binomial distribution. N equals 8, P is equal to 0.38. I want to find the probability that X is greater than or equal to 1. And so let me use StatDisk to do this. And so I have here, first, go to StatDisk, click on Analysis menu, and then from the probability distributions, click on Binomial Distribution. And so now, let's put in the number of trials, 8. The probability of success, 0.38. And I want to do everything from X greater than or equal to 1. So let's plug in 1. So if you do that, you look over here, and you see that you get the probability X is greater than or equal to 1 is 0.978181 660. Okay, so let me type that into my computer. And so we have there. And so I have 0.97816660. Move my decimal place 2 places to the right, 97.81660%, round to the nearest hundredth of a percent. And so I have 97.82%. Let me do problem number 6. In the town of Maplewood, a certain type of DVD player is sold at just 2 stores. 58% of the sales are from store A, and the rest of the sales are from store B. 7% of the DVD players sold at store A are defective, while 8% of the DVD players sold at store B are defective. If Kate receives one of these DVD players as a gift and finds that it is defective, what is the probability that it came from store A? Express your answer as a percentage rounded to the nearest hundredth without the percent sign. And so I have here that, well, we have 2 stores, store A and store B. We have that 58% of the sales are from store A, and the rest are from store B. So 58% are from store A, and the rest are from store B. And so, well, if I have a 58% probability of success, I have a 42% chance of failure. And so there's a 42% of the sales are from store B. Let D denote the fact that the DVR is defective, and N, the fact that the DVR is not defective. So we have that 7% of the DVDs from store A are defective, whereas 8% of the DVD players from store B are defective. So 7% from store A are defective, whereas 8% are defective from store B. Well, if 7%, if I have a 7% chance of success, I have a 93% chance of failure. For 8% chance of success, I have a 92% chance of failure. And so 93% of those DVD players from store A are non-defective, whereas 92% of those DVD players sold from store B is non-defective. I want to find the probability that of A, that the DVD player is from store A, given that the DVD player is defective. And so I want to find the probability of A given D. Well, I can find the probability that is defective, given that it's from store A. But if I know that it's defective, well, I don't know if it's from store A or store B. Therefore, I have to use Bayes' theorem. And so I want to look at all those that are defective. So let me multiply 0.58 times 0.07, 0.0406. That's 5.42 times 0.08, 0.0336. Those are the only ones that are defective. So let's add these up. So I get 0.0742. That will be my denominator. I want that it's from store A. And so my numerator is 0.0406. And so I get 29 over 53, 0.54716981113. Let's move my decimal place 2 places to the right. And so 54.716981113%. Let's round to the nearest hundredth of a percent. So 54.72%. Problem number 7. How many ways can 3 people be chosen and arranged in a straight line if there are 11 people to choose from? And so this is going to be an ordered arrangement. And so we're going to be using a permutation. So I'm going to look at NPR. And so I have 11 and I'm choosing 3 of them. So for the first one, there are 11 people I can first choose to be the first person in line. After I've chosen that first person, then there are only 10 people remaining that I can choose from to be in line. After I've chosen the second person, there's only 9 remaining. I can also use permutation, NPR. And so let's click on Math. Let's go to the PRB menu and let's select NPR. Oops, sorry. Let's input 11. Let's click on Math. Let's go to the PRB menu and select NPR. And I want 3 of them. And so I get 990. Okay, so let's put that number into my laptop. And so I have here that inputting 11 in PR, 3, I get 990. I could also use Excel to do this. And so let me use Excel. And so with Excel, I'll be using the command permute 11, 3. So let me do that. And so I have here permute 11, comma 3. And so I get 990. And so let me input that into my laptop. So let's write that down. And so we get that 11p3 using the permute 11, comma 3 command is 990. Let me do problem number 8. Library is to be given 5 books as a gift. The books will be selected from a list of 18 titles. If each book selected must have a different title, how many possible selections are there? Okay, so in this case, it doesn't matter the order at which you're selecting these. And so because of that, we'll be using a combination. And so we'll be looking at the NCR. And so in this case, well, there are 18 books, and we're going to be selecting 5 of them. And so 18, choose 5. And so I have 18 times 17 times 16 times 15 times 14. I start with 18 and I write down 1, 2, 3, 4, 5 numbers. Divided by factorial, 5 times 2. Well, 15 divided by 5 is 3. 16 divided by 4 is 4. 18 divided by 6 is 3. Times 17 is 51. Times 12 times 14 is 8563. And so I could also do this using technology. So let me do this on the TI-83/TI-84. And so I'm going to do 18C5. And so let's input 18, click on Math, go to the PRB menu. It's the third one down. And let's select 5, hit enter. And so you get 8568. Let me type that into my laptop, into my iPad. And I have here CR5, and I get 60. Let me use Excel using the combine formula. And so I'll do 18C5 will just be combine 18, comma 5. So let me do that on my computer. And so I have here combine 18C5. And I get 8568. Okay. Let me write that on my iPad. And so I have here that if I were using Excel, then I would get 8565. I could also use Mathematica to do this. And so let me do 18C5. In this case, I'm going to be using the binomial coefficient in Mathematica. So I'm going to be doing binom 18, comma 5. Okay, so let me do that. Type in that command. And so I have here the binomial 18, comma 5. And so I get 8568. let me write that on my iPad. And so we have, 8568. I could also use R to do this. So let me show you how to do this in R. And so I'll just use the choose command in R. And so let me type in choose 18, 5. And so again, I get 8568. Let me type that into my iPad. Okay. So using the R, I get 8568. Problem number 9. Find the missing value required to create a probability distribution, then find the standard deviation for the given probability distribution. Round to the nearest hundredth. So in this case, well, we have here a distribution that is missing one number. Note that in order for us to have a discrete probability distribution, that all the probabilities here must be greater than or equal to 0, and they must add up to 1. So I have to have that all the probabilities are greater than 0, and they must all add up to 1. So therefore, whatever is missing must be the difference between the sum of these values and 1. And so let's do 1 minus 0.02 plus 0.18 plus 0.11 plus 0.06, 0.63. We also want to find standard deviation for this distribution. So I must attach 2 additional columns to my distribution, the x p of x column and the x squared p of x column. So to get the third column, the x p of x column, I multiply first and second column. 0 times 0.02, 0. 1 times 0.63, 0.63. 2 times 0.18, 0.36. 3 times 0.11, 0.33. 4 times 0.06, 0.24. To find the fourth column, I'll multiply the first and third column to get the fourth column, the x squared p of x column. 0 times 0, 0. 1 times 0.63, 0.63. 2 times 0.36, 0.72. 3 times 0.33, 0.99. 4 times 0.24, 0.96. Let's add up each of the columns. So this adds up to 1. Good. That means that this is a discrete probability distribution. Let's add up this column. I get 1.56. Let's add up this column here. So I get 3.3. So my variance is the sum of the last column, the x squared p of x column, 3.3, minus the square of the sum of the previous column, the x p of x column, 1.56 quantity squared. And so I get 0.8664. To find the standard deviation, I'll take the square root of the variance. And so the square root of 0.8644. Therefore, the standard deviation is 0.9308061023. I want to round to the nearest hundredth, and so 0.93. Let me do problem number 10. A 28-year-old man pays $228 for a 1-year life insurance policy with coverage of $13,671 if the probability that he will live through the year is 0.995, what is the expected value for the insurance policy? Round to the nearest cent. Okay, so I want to find the expected value. So let us set up a table here, a probability table to determine. And so we have that there is a 99%, 90.995 probability that he will live throughout the year. And so there's a 0.995 probability that he lives throughout the year. Therefore, there is a 0.005 probability that he does not live throughout the year, a year longer. He must pay $228 for his life insurance policy. If he lives, well, he's paid $228 and that just goes down the drain. And so he loses the $228. However, if he does not live, he dies within 1 year, then the insurance policy pays him $13,671. He had to, however, pay $228 for that. And so he will have made $13,448 if he dies within 1 year. Let's find the expected value. And so the expected value is just the sum of x plus. And attach this additional the xp of x column. Let's multiply the first and second column to get the third column. Oops. The first and second column here to get the third column. And so negative 228 times 0.995 is negative 226.86. Let's multiply 13,448 times 0.005 to get 67.215. Let's add these up. So I get a negative 159.645. Therefore, the expected value of the insurance policy is a negative $159.64. So you expect that you will lose some money because you don't, it's very unlikely that you're going to die within the first year. Problem number 11. According to a college survey, 84% of all students work full-time. Find the standard deviation for the number of students who work full-time in the sample of size 219, rounded to the nearest 100. So this is a binomial distribution. We have a fixed finite number of independent trials, 219. Success is that they work full-time. The probability of success is 0.84. I want to find the standard deviation. And so let's find the variance for the binomial distribution. So the variance is given by NPQ. So N is 219, P is 0.84. If I have an 84% chance of success, I have a 16% chance of failure. So Q is 0.16. Let's multiply these together. So I get 29.4336. And so to find the standard deviation, I'll be taking the square root of the variance. Well, the square root of 29.4436 is 5.42574187. Let me round that to the nearest hundredth. And so 5.43. Problem number 12. An archer is able to hit the bullseye 42% of the time. If she shoots 12 arrows, what is the probability that she does not get exactly 4 bullseye? Assume that each shot is independent of the others. Express your answer as a percentage rounded to the nearest hundredth. So in this case, we have that this is a binomial distribution. We have a fixed finite number of independent trials, 12. We have that success is that the archer here hits a bullseye. We have that the probability of success is 0.42. We want to find the probability that she does not get exactly 4 bullseyes. So I want to find the probability that X is not equal to 4. So let's look at the complementary event. 1 minus the probability that X is equal to 4. And so let's calculate this using the binomial probability formula. And so 1 minus N12 CR, which is 4, times P, which is 0.42 to the power 4. If I have a 42% chance of success, I have a 58% chance of failure. So Q is 0.58 to the power 12 minus 4, which is 8. And so I get 0.8027457773. Let me move my decimal place 2 places to the right. And so I have 80.27457773%. Let me round this to the nearest hundredth of a percent. And so I get 80.27%. Let me use the TI-83/TI-84 to do this. So again, this is a binomial distribution with N equal 12, P equals 0.42. To find the probability X is not equal to 4, I'll do the complementary event. 1 minus binom PDF, 12, 0.42, 4. So let me do this on my TI-83/TI-84. And so let me input 1 minus binom PDF. So second distributions. So the binomial PDF. I have here 12 trials. I have a 0.42 probability of success, and I do not want that X is equal to 4. And so I have 0.8027457773. Let me write that down on my iPad. And so we have here that 1 minus binom PDF 12, 0.42, 4 is 0.0827457773. Let me move my decimal place 2 places to the right. So 80.27457773%. Let's round to the nearest hundredth of a percent. And so 80.27%. Well, if you're going to be using Excel to do this, then again, we have a binomial distribution with N equals 12, P equal 0.42. I want to find the probability that X is not equal to 4. So I'll do 1 minus binomial distribution, 4, 12, 0.42, and we're going to be using a PDF, and so it'll be false. And so let me do that on my Excel. And so let me input 1 minus binomial distribution, so binom distribution. I have, I do not want X equal 4. I have 12 trials, and I have a probability of success of 0.42, and I want this to be a PDF, so this will be false. And so I have here 0.8027457773. 0.274578. Let me write that on my iPad. And so I have here 1 minus binomial of 0.42 false gives me 0.8027458. Let me move my decimal place 2 places to the right. And so I have 80.27458%. Let's round to the nearest hundredth of a percent. So 80.27%. We could also use Mathematica to do this. So if you were using Mathematica to complete this, then, well, again, we have a binomial distribution with n equal 12, p equal 0.42. We want to determine the probability x is not equal to 4. And so I will type in the command 1 minus PDF binomial distribution 12 comma 0.42 comma 4. And so let me do this in Mathematica. And so let me type in 1 minus PDF for the binomial distribution with parameters. There are 12 trials with a probability of success of 0.42. And I want to get rid of x equal 4. Oh, I'll get the exact amount, and I will also do this numerically. To 10 decimal places. Oops. Oh, there's 0.42. I don't have, it's already numerical. And so 0.802746. Let me type that into my iPad. And so we have 0.802746. Let me move my decimal place 2 places to the right. So 80.2746%. Let me round to the nearest hundredth of a percent. So 80.27%. I could also use R. So if I was using R, then we will solve the problem in the following fashion. Again, we have a binomial distribution. So n is equal to 12, p is equal to 0.42. I want to find the probability that x is not equal to 4. And so I'll do 1 minus d binom 4 comma 12 comma 0.42. So let me type that into R. And so I have here 1 minus d binom 4 comma 12 comma 0.42. And so I get 0.8027458. Let me type that into my iPad. And so I have 0.8027458. Let me move my decimal place 2 places to the right. And so I have 80.27458%. Let me round to the nearest hundredth of a percent.
Steve,
and
we
so
don't see the iPad.
80.27%.
Can you show the iPad?
Yes. Yes. Sorry.
Yeah, I'm keeping you honest here. Yeah, thank you.
I'm switching in between several things.
Yeah.
There's one thing that came up. I didn't hit it. Thank you.
You're welcome.
I'm using. I have to use more than one computer.
Yeah, I can
That's
see
why
that.
it takes a little while to transition. Okay, but thank you very much. Okay, so 1 minus d binom. Yeah. So 1 minus d binom 4 comma 12 comma 0.42. So I get 0.8027458. Let me move my decimal place 2 places to the right. So 80.27458%, round hundredth of a percent. So 80.27%. If you were using StatDisk Online, then again, again, we will have a binomial distribution with n equal 12, p equals 0.42. I want to find the probability that x is not equal to 4. And so let me do that. And so here it is. So let's go up to analysis, click on probability distributions and binomial distribution. And so I have here that n is equal to 12. The probability of success, p, is 0.42. And I want x equal 4. So in this case, when you evaluate it, you get 1972542. And so I'm going to have to write that number in my iPad. But when I do that, I'm going to have to now actually do some arithmetic here. So when using StatDisk Online, it's going to require you to do a little bit of arithmetic. And so I have here 1 minus the number I just saw in StatDisk Online, 0.1972542, which gives me 0.8027458. Let me move my decimal place 2 places to the right. So 80.27458%. Let's round to the nearest hundredth of a percent, 80.27%. Problem number 13. A survey for brand recognition is done, and it is determined that 41% of consumers have heard of Dell Computer Company. A survey of 16 randomly selected consumers is to be conducted. For each such group, would it be significantly high to get 2 consumers who recognize the Dell Computer Company name? Why or why not? Explain your answer using descriptive statistics and or probability appropriately. If your reasoning requires a z-score, enter the z-score rounded to the nearest hundredth. If your reasoning requires a probability, enter the probability as a decimal rounded to the nearest 10,000. Well, this is going to be a binomial distribution since we are doing random selection. And so each of the trials will be independent. We have here that n is equal to 16. And we have success is that they have heard of the Dell Computer Company. And we have a fixed probability of success for each trial, 0.41. I want to find the probability that x is greater than or equal to 2. In this case, well, it'll be easier to use the complementary effect. So let's use the complementary effect. 1 minus the probability that x is less than 2. And so in this case, well, the things that are less than 2 are 0 and 1. So let's find the probability that x is 0 and the probability that x is 1. And so 1 minus the probability x is 0. So I have here is 16, and I want no successes, so 16 C0. I have p is 0.41 to the power 0. If I have a 41% chance of success, I have a 59% chance of failure. So 0.59. 16 minus 0 is 16. Let's find the probability that x is equal to 1. So again, n is 16, c 1. I have p is 0.41 to the power 1. Again, q is 0.59 to the power 16 minus 1, which is 15. And so I get 0.99738732. Let's round this to the nearest 10 thousandths, 0.9974. Since this probability is greater than 0.05, that means that we are not in the rejection region. And so since we're not in the rejection region, no, this is not sufficiently high. No, this is not significantly high because the p-value is greater than 0.05. So this was not by pure chance. It was not due to statistical fluctuation. If you're using 84, then the way that you would approach this problem is, well, again, this is a binomial distribution with n equals 16, p equal 0.41. I want to find the probability that x is greater than or equal to 2. And so I'll look at the complementary event, 1 minus the probability that x is less than or equal to 1. So I'll type in the command, 1 minus binom CDF, 16, comma 0.41, comma 1 into the TI 83/84 calculator. So let me do that. And so let me type in 1 minus binom CDF. I have 16 trials. I have the probability of success is 0.41. And I want to get rid of everything less than or equal to 1. So in order to get everything greater than or equal to 2. And so I get 0.99738,732. Let me type that into my iPad. There. And so I have here 0.99738732. Let's round this to the nearest 10 thousandths, 0.9974. Since the probability x is greater than or equal to 2 is greater than 0.05, then no, this is not significantly high because the p-value is greater than 0.05. This was not by pure chance. It was not due to statistical fluctuation. If you were instead using Excel to answer this question, well, again, we have that this is a binomial distribution. We had that n here is equal to 16. P is equal to 0.41. I want to find the probability that x is greater than or equal to 2. And so let's do the complementary event. 1 minus the probability x is less than or equal to 1. So in this case, we're going to be using the binom distribution function. So binom.dist. And we're going to be doing an inequality. So we're going to be doing true. And so 1 minus binom dist. I want to get rid of everything less than or equal to 1. So 1, 16.41 true. Okay, so let's do this on my in Excel. Let's type this into Excel. And so 1 minus binom distribution. Oops. And we have, I want to get rid of everything less than the 1. I have 16 trials with fixed probability of success 0.41. And I want this to be cumulative. And so I get 0.99738 0.9732. Let me type that into my iPad. And so I have 0.99738,732. Round this to the nearest 10 thousandths. 0.9974. I have that since the probability that x is greater than or equal to 2 is greater than 5% alpha, then no, this is not significantly high because the p-value is greater than 0.05. This was not by pure chance. It was not due to statistical fluctuation. Okay, so if you were using, and again, this is a binomial distribution, we have that n is equal to 16, p is equal to 0.41. I want to find the probability that x is greater than or equal to 2. And so I'll use the complementary event, 1 minus the probability x is less than or equal to 1. And so 1 minus, well, we have an inequality, so we'll be using CDF. We have a binomial distribution, and we have parameters 16 and 0.41, and we want to get rid of everything less than or equal to 1. Okay, so let me do this in Mathematica. So let me type this in. And so I have here 1 minus CDF for the binomial distribution with parameters 16 and 0.41. And I want to get rid of everything less than or equal to 1. And so I have 0.997387. Let me type that into my iPad. And so I have point 997387, rounding to the nearest 10 thousandths, I have 0.9974. Since the probability x is greater than or equal to 2 is greater than alpha, then no, this is not significantly high because the p-value is greater than 0.05, the typical alpha value for alpha. This was not by pure chance. It was not due to statistical fluctuation. If instead you want to use R to answer this question, then, well, again, it's a binomial. This is a binomial distribution. N is 16, P is 0.41. I want to find the probability that x is greater than or equal to 2. So 1 minus the probability x is less than or equal to 1. So 1 minus P binom 1, comma 16, comma 0.41. And so let me type that into R. And so 1 minus P binom of 1, comma 16, comma 0.41. And so I get 0.9973873. Let me type that into my iPad. And so I have 0.9973873, rounding to the nearest 10 thousandths, I have 0.9974. And so the probability that x is greater than or equal to 2 is greater than 0.05. So no, it is not significantly high because the p-value is greater than 0.05. This was not by pure chance. It was not due to statistical fluctuation. If you decide to do this problem using StatDisk Online, then this is a binomial distribution. N is 16, P is 0.41, I want to find the probability that x is greater than or equal to 2. And so let me type that into StatDesk. And so if you type this into StatDesk, you have the following. So let's, again, you click on Analysis, Probability Distribution, the binomial distribution. And we have here that n is 16, p is, n is 16, p is 0.41, and x is equal to 2. And if you do that, well, to find the probability x is greater than or equal to 2, we have that the probability x is greater than 2 is equal to 0.997 3873. And so let me type that into my iPad. So I have here 0.9973873. Round this to the nearest 10 thousandths, 0.9974. Since the probability x is greater than 2 is greater than 0.05, then we have that no, this is not significantly high because the p-value is greater than 0.05. This was not by pure chance. It was not due to statistical fluctuation. Problem number 14.
Steve,
A naturalist leads whale-watch trips every morning in March. Yes.
I'm just gonna
Yes.
leave, okay?
Yes.
Okay, bye.
Okay. Bye right now. Okay. Problem 14. A naturalist leads whale-watch trips every morning in March. The number of whales seen has a Poisson distribution with a mean of 1.34. Find the probability that on a randomly selected trip, the number of whales seen is 4. Express your answer as a percentage rounded to the nearest hundredth. So we have a Poisson distribution. I have that mu is equal to 1.34. I want to find the probability that x is equal to 4. So let's use the Poisson probability formula. Mu to the x e to the minus mu over x factorial. And so mu here is equal to 1.34. X here is equal to 4. And so I get 0.0351765583. Let's move my decimal 2 places to the right. So 3.51765583%. Round this to the nearest hundredth of a percent. So 3.52%. If you were solving this using your TI-83, TI-84, then again, this is a Poisson distribution. Mu is equal to 1.34. I want to find the probability x is equal to 4. And so let's type in the following command. So I will type in Poisson, distribution. So I'll do the Poisson distribution. And this will be a Poisson PDF. Let's try that again. I'll type in the Poisson distribution, the Poisson PDF. I have that mu is 1.34 and x is equal to 4. And so you get 0.035176553. Let me type that into my iPad. And so we have I wanted to find the probability x is equal to 4. And so I did the Poisson PDF. 1.34 comma 4 is 0.035176553. Let me move my decimal place 2 places to the right. 3.5176553%. Let's round to the nearest hundredth of a percent. 3.52%. Using Excel, we again have that this is a Poisson distribution with mu equal 1.34 and x equals 4. So let's do Poisson.dist 4 comma 1.34 comma false. And so let me type that into my Excel. And so I have here Poisson distribution. And I have, I want to figure out when x is equal to 4, when mu is 1.34, and we want this to be a PDF, so false. And so 0.0351766. So let me type that into my, let me type that into my iPad. And so Poisson.dist 4 comma 1.34 false, 0.0351766, move in decimal place 2 places to the right, 3.51766%, round to the nearest hundredth of a percent, 3.52%. So if you're using Mathematica, then again, we have a Poisson distribution, mu equal 1.34. I want to find the probability x is equal to 4. Since it's equality, I'll be using PDF. So PDF Poisson distribution 1.34 comma 4. So let me type that into Mathematica. And so let me type in PDF for my Poisson distribution with parameter 1.34. And I want to find the probability that x is equal to 4. Oops. That x is equal to 4. So I get 0.0351766. Let me type that into my iPad. And so I have .0351766. Let's move my decimal place 2 places to the right. So 3.51766%. Let's round to the nearest hundredth of a percent. So 3.52%. If you're using R, then this is a Poisson distribution with mu equal 1.34. So I want to figure out the probability x is equal to 4. So you use d points 4 comma 1.34. So let me type that into into R. And so I have here d Poisson 4 comma 1.34. And so I get 0.0351766. And so let me type that into my iPad. And so I have here 0.0351766. Let me move my decimal place 2 places to the right. So 3.51766%. Let's round to the nearest hundredth of a percent. So 3.52%. If you're using StatDisk Online, then let me type that in. And so we have Poisson distribution, mu equal 1.34. And so I want to find a probability that x is equal to 4. So let me do that. So let's go to analysis, probability distribution, the Poisson distribution. And so in this case, we have 1.34. And I want to figure out when x is equal to 4. And so I have here 0.03518. And so let me type that into my iPad. And so I have point 0.3518. Let's move my decimal place 2 places to the right. So 3.518%. Let's round to the nearest hundredth of a percent. So 3.52%.